All right, let's dive right in. Today, we're going to get our hands dirty with some advanced algebraic manipulations. We're going to see how we can turn these problems that look super complex into puzzles that are actually pretty simple to solve.
You ever been there, staring at a long, complicated equation and just feeling stuck? Yeah, you're definitely not alone. These concepts can be really tricky, but they absolutely do not have to be a roadblock for you. So let's try to reframe how we think about this. We're not just going to be memorizing a bunch of boring rules. Nope, we are building a powerful problem-solving toolbox. Every single technique we cover today is a brand new tool you can pull out to take apart and solve any algebraic challenge that comes your way. Okay, our first tool for the kit is a set of awesome shortcuts. We're talking about algebraic identities. Seriously, don't think of these as formulas you have to memorize. Think of them as secret passages that let you bypass all the long, tedious work. First up, the square of a sum, a plus b squared. Now you could multiply this out the long way step by step, but why would you? This identity is your direct shortcut. The answer is always going to be a squared plus 2ab plus b squared. It's clean, it's fast, and it's a fundamental pattern you want to get really good at spotting. And right next to it in the toolbox is its twin, the square of a difference, a minus b squared. See how similar it is? The pattern is almost identical. The only thing that changes is that the middle term flips to negative, giving us a squared minus 2ab plus b squared. It's just a really elegant and simple pair of tools. Okay, now this one, the difference of squares, is one of the most powerful tools for simplifying things, period. When you see this pattern of a plus b times a minus b, you can immediately just jump straight to the answer, a squared minus b squared. Trust me, this shortcut pops up absolutely everywhere. And get this, these shortcuts aren't just for two terms. Look how neatly this identity expands, a plus b plus c squared. The pattern is so simple once you see it. You just square each term by itself, a squared, b squared, and c squared. And then you add twice the product of each pair. It turns what would be a super tedious multiplication into a totally straightforward process. And finally, let's look at powers of 3 with the cubic expansion of a plus b cubed. Recognizing this pattern is huge. These identities are, without a doubt, the building blocks of algebra. Once you master them, you'll start seeing these shortcuts everywhere, and you'll save yourself so much time and effort. So we've seen how to build expressions up, but what about taking them apart? That's where our next tool comes in, factorization. If identities are for building, factorization is our deconstructor tool. It's for breaking down those big, messy expressions into their simple core pieces.
Now, factorization isn't just guesswork, it's a system. First thing you do, always, is look for a common factor you can just pull out from every term. After that, you can try grouping terms together that look like they might share a factor. And hey, you can even use the identities we just learned, but backwards. And for quadratics, a really powerful move is splitting that middle term to help you group and factor. It's a solid step-by-step approach.
And the result? Oh, it's so satisfying. To factor something like x squared plus 5x plus 6, we're just looking for two numbers that multiply to 6 and add up to 5, which are, of course, 2 and 3. And just like that, you've deconstructed the expression into a simple product, x plus 2, x plus 3. And once it's in this form, solving for x is suddenly incredibly easy. All right, next up in our toolbox is the simplifier. We're talking about algebraic fractions, or what are sometimes called rational expressions. Yeah, they can look pretty intimidating, but with this tool, we're going to clean them up and make them totally manageable. Here's the secret. The logic is exactly the same as it is with simple numbers. I mean, how do you simplify 10 over 15? You find the common factor, which is 5. Well, for the algebraic fraction on the right, we do the same thing. First, we factor the top part into x plus 1, x plus 2. And now, look at that. You can see the common factor is x plus 1 on both the top and bottom. So we can just cancel it out and simplify the whole thing. And what if you run into this monster, a fraction inside another fraction? Don't panic. The key is so simple. You just multiply the top fraction by the reciprocal, the flipped version of the bottom one. That one single move untangles the whole messy expression. So far, we've pretty much been focused on things that are equal. But, a lot of math is also about comparing things. So let's add the comparator toolset to our kit. This is what helps us understand relationships using inequalities and variation.
When you're solving inequalities, you can basically treat them just like you would a regular equation. Add, subtract, multiply, divide, go for it. But, and this is a big but, there is one critical rule you have to remember. If you multiply or divide both sides by a negative number, you must flip the inequality sign. That's the one thing that can trip you up.
Variation is just a way to describe how variables change together. In direct variation, when x goes up, y goes up. In inverse variation, when x goes up, y goes down. And in joint variation, y changes based on two or more other variables. In every single case, that letter k is the constant of proportionality. It's the specific number that links them all together.
And there you have it. We've just put together a fantastic collection of algebraic tools. So let's do a quick recap of what's inside your brand new, ready-to-use math toolbox.
You are now officially equipped with time-saving identity shortcuts for super fast expansions. You've got the factorization deconstructor to break down even the most complex expressions. You have the simplifier for taming those wild rational expressions, and the comparator toolset for dealing with inequalities and variation. You are ready to go.
These aren't just rules on a page anymore. They are active, powerful tools just waiting for you to use them. So really, the only question left is, with this amazing new toolbox at your fingertips, what problem are you going to solve first?